Hello students, welcome to my channel. Today in this video we are going to see the introduction of squares and square roots and all the Trythese problems before exercise 6.1. Okay, see here, square means multiplying the number 2 times. Okay, 1 square 1 into 1, 2 square 2 into 2, 3 square 3 into 3. So 1 into 1 1, 2 into 2 4, 3 into 3 9, 4 square 4 into 4 16. Okay, and square of a number means multiplying the same number 2 times. So these now 1 4 9 6 are called squares. Okay, and we can say perfect squares. Okay, so that means square root of 4 means 2, square root of 9 3. So by multiplying which number 2 times we are getting 9? 3. Square root of 25 means by multiplying which number 2 times we are getting 25? 5. Okay, so like this, squares and square roots. It's a very easy chapter. Okay, so first of all, so 1 4 9 6 and 25 36, all these numbers are called square numbers. Okay, see here in our textbook they give, in general, if a natural number m can be expressed as n square, where n is also a natural number, then m is a square number. If a number m can be expressed as the product of one number 2 times, then m is a square number. N into n means n square. So here number square 1, 1 into 1 1, 2, 2 into 2 4, 3, 3 into 3 9, 4 into 4 16, 5 into 5 25. Now 6 into 6 36. Here 7 into 7 49, 8 into 8 64, 9 into 9 81, 10 into 10 100. Okay, so like this you can complete this table. So from this table we can write square numbers between 1 and 100. See, 1 4 9 16, the square numbers start from 1 and ends with 1. 100, right? So we can write, and all these numbers 1 4 9 16 25 are called perfect squares. All these numbers are called perfect squares. Okay, so it's very easy. Next, see here, one try this. Find the perfect square number between 30 and 40 and 50 and 60. See here we have between 30 and 40. Only 36 is the number between 30 and 40 we have, right? So you can write 36 is the perfect square number between 30 and 40. And to this second one, 50 and 60. See, there is no number between 50 and 60. Okay, so same thing you can write. So like this you can simply write the answer for this. Try this. Next, properties of square numbers. See, 1 square means 1, 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25. Okay, now see, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100. Okay, and we can write up to 25. Now see, every square of a number ends with 1 4 9 6 5 and 0. See, 196, and here also 6941. Okay, so clearly we can say perfect squares ends with 0 1, 4, 5, 6 and 9. Okay, if a number has any one of these numbers 0, 1, 4, 5, 6 or 9 in its units place, we can say it may be a perfect square. Maybe, not exactly we can tell, it may be a perfect square. Okay, and clearly we can tell 2, 3, missing numbers 2, 3, 7, 8. If any number has 2, 3, 7, 8 in units place, clearly we can say it's not a perfect square. So in general in the society also like that only, na, negatives only others will tell, damn sure he is very bad, just like that the people will tell, no. So here also not perfect square, we can tell if any number has 2, 3, 7, 8 in the units place, we can tell it is not a perfect square, surely we can tell. And if any number has 0, 1, 4, 5, 6, 9 in its units place, it may be a perfect square. Okay, so these are the properties of perfect square till now. Okay, so here we have, so basing on this we have one, try this. Can we say whether the following numbers are perfect squares? How do we know? Okay, so these are perfect squares or not, how do we know? So to write the answer, just keep it in the mind. 2378 is in units place. That is not a perfect square. Otherwise, it may be a perfect square. So here, 7 is there in the units place. So clearly we can tell not perfect square. How do we know? Also they are asking. So reason we can write 7 in units place. Okay. So like that. 3. So 3 is there, not a perfect square. Again 3 in units place. So 8, 8, not a perfect square. So 8 in units place. Reason, how do we know, they are asking in the question. So 2 is there in the units place, so not a perfect square. Why? 2 in units place. 9, if 9 is there in the units place, it may be a perfect square, right? It may be, we cannot tell surely. So 9 in units place. 1 is there, it may be a perfect square. So reason 1 in units place. So like this you can write, students. Next, in the same question they are asking, write 5 numbers which you can decide by looking at the unit digit that they are not square numbers. Not square numbers means just the numbers which have 2, 3, 7, 8 in units place. They are not squares, right? So you can write any 5 numbers. So 5 numbers that are not square means 1037. 7 is in the units place. 25, 2, 3. 3 is in the units place. Next 4, 5, 7, 6, 2. 2 in units place, not square. Next 9, 8, 7, 6, 8. 8 is there in the units place, not square number. Okay. Next 2, 3, 7, 8 only, na? So you can write any other number. 7, 5, 6, 2, 3. 3 is that in the units place. So it is not a perfect square. So you have to remember this. If any number has 2, 3, 7 or 8 in the units place, those numbers are not squares. In the second question they are asking, write 5 numbers which you cannot decide just by looking at their unit digit or units place whether they are square numbers or not. So just by looking we cannot take one decision that number is a square number or not. So I explain now only, if any number has 0, 1, 4, 5, 6, 9 in the units place, it may be a perfect square. We cannot tell surely it is a perfect square. It may be, right? So you can write any 5 numbers which have 0, 1, 4, 5, 6, 9 in their units place. Okay, any numbers up to your choice you can write. 5, 6, 9, 3, 9, 5. We cannot tell. These are squares. So 9, 5, 2, 3, 4. 4 numbers are completed. And 2, 3, 4, 1. So like this you can write. So the main point here you have to keep in your mind is, if a number has 2, 3, 7, 8, those numbers are not perfect squares in their units place. And if the number have 0, 1, 4, 5, 6, 9 in the units place, it may be a perfect square. So these are the try these problems in page number 90. So next, here 1 square, 1, 9 square, 81. 1 is there in the units place, right? 11 square, here 1 is there in the units place, and here also 1. 9 is in the units place 1. So you can conclude that if a number has 1 or 9 in the units place, square has 1 in units place, right? If a number has 1 or 9 in the units place, its square's units place is 1. Similarly, see 2 square, 4, 8 square also in the units place, I'm saying 4. Here in the units place 2 is there, 4 came. In the units place 8, 4 came. 2, 4. So we can conclude, if a number has 2 or 8 in the units place, its square have 4 in their units place. Are you following, students? Now see, 3 square 9, 7 square 49. So units place 3 is there, so it is 9, and units place 7 is there, 9 came. Units place 3, so square units place 9. So you can conclude 3 or 7 is there in the units place of a number. The units place of its square definitely will have 9. Okay, next, see 6 is there, 4 square 16, 6 square 36. Here 4 is there, 6 is there, again 6, 4 is there, 6 came. So we can conclude, if any number has 4 or 6 in its units place, its square definitely ends with 6. Okay, and see 5 square 25, 15 square 225, 5, 25 square 5. So if a digit has 5 in the units place, its square also have 5 in the units place. So it will be very useful to solve the problems. Okay, students, very easily you can remember this. Okay, so pattern also, if you write like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 and 9, 8, 2, 3, 7, 4, 6 and 5 will be the one. Very easily you can remember. Now see these, try these problems. Which of 123 square, 77 square, 82 square, 161 square, 109 square would end with digit 1? See, to end with digit 1, all these squares, no? To end with digit 1, it must have 1 or 9 in the units place. So our answer will be 161 and 109. 161 square and 109 square. So answer for this. Next, try this. Which of the following numbers would have digit 6 at units place? So to have 6 at units place, the number must have 4 or 6, right? So 4 or 6, 24, 26, 36, 34 square. So these four numbers will have 6 at units place. Students, very easy it is. I think you are understanding. Okay. So now page 92, try this. What will be the ones digit in the square of the following numbers? So we learned now this one. So just by using this easily we can write. So given number ones digit 4. Just write ones digit here 7, 8, 0, 2, 6. Okay. If 0 is there in the ones digit, its square ones digit also 0. Okay. See, 4 is there. 4 is there means ones digit of its square 6. If 7 is there, ones digit of its square 9. 8 means 4. 0 means 0. 2 means 4 in its square. 6 means 6 in its square. So otherwise 4 4s are 16, 6 7 7s are 49, 9 8 8s are 64, 4 0. How many times you multiply it? 0 into 0 means 0 only. 2 2s are 4, 6 6 are 36. So in the units place 6. Like that also you can write. It's better to keep these points in the mind. Okay. So next just observe this. If a number has 1 0, in its square has 2 zeros. Okay. If a number has 2 zeros, in its square has 4 zeros. Similarly, if a number has 3 zeros, in its square has 6 zeros, right? So the zeros number will be double. Okay. So just remember that point. And another important point here, you have to remember number with even zeros may be a perfect square. PS means perfect square. Number with odd zeros never be a perfect square. For suppose if I ask 1500, you can tell it may be a perfect square. Okay. And similarly 15,000 I asked, you can clearly tell it is not a perfect square. Why? Odd number of zeros are there. Okay. You know the odd numbers 1 3 5 7. The numbers which are not divisible by 2 are called odd numbers, right? So you can tell like this. Okay. Next problem, try this. The square of which of the following numbers would be an odd number or an even number? Why? So next one you have to remember, if a number is odd, then its square number is also odd. If a number is even, then its square number is also even. Okay. See, y means if we square an odd number only comes. If we square even number comes. Okay. So if odd number is there, then its square also odd. If even number is there, then its square also even. No confusion. It's clear. Okay. So the square of which of the following numbers would be an odd number and or an even number? Y. So these are the problems we have. 727. Digit in the units place 7. 7 is odd. So it's a square also odd. Okay. Y means this is the reason. Here digit in units place 8. It is even. So it's square also even. So here units place 9. It is odd. So square also odd. So 0 is even, right? So any number which contains 0 in the units place is divisible by 2. That is the divisibility rule of 2. Okay. A number which ends with 0, 2, 4, 6, 8, that will be divisible by 2. So this is even number. So the square also even. Okay. So like this you can easily write. Next one, see, What will be the number of zeros in square of the following numbers? If one zero is there, in square, two zeros. In square, two zeros. Okay, and two zeros are there, no? So in the square, four zeros. That's it. Four zeros are there in 400 square. Two zeros are there in 60 square. Like that, you can write. Next, see 1 square, 1, 2 square, 4. So between numbers 2, 3, right? So that means two numbers. Okay, how many numbers between 1 square and 2 square? Two numbers. So I can tell 2 into 1, 2, right? Next, 2 square, 4, 3 square, 9. How many numbers? 5, 6, 7, 8. 4 numbers, right? So 4 means 2 into 2 only, no? I'm multiplying these two. Okay, so 4. Next, you see 3 square, 9, 4 square, 16. How many numbers between 9 and 16? 10, 11, 12, 13, 14, 15, right? 1, 2, 3, 4, 5, 6. So this 3. 2 into 3, 6. So clearly we can conclude these are the successive numbers. That means n and n plus 1. 3, 3 plus 1 only, no? 4. So between any two squares of successive numbers, there are 2n natural numbers or non-perfect square numbers. So this is the formula you have to remember. Okay, see, non-perfect squares or natural numbers between n square and n plus 1 square is 2n. Okay, that's the formula you have to remember. See now, try this page number 94. How many natural numbers lie between 9 square and 10 square, between 11 square and 12 square? So these two are successive numbers only, na, 9 and 10. So just multiply the first number with 2. 2 into 9, 18 is the answer. 11 and 12 consecutive numbers. Okay, side by side numbers. So 2 into 11, just double or multiply with the 2. 2 11s are 22. Here also same. How many non-square numbers lie between the following pair of numbers they are asking? So 100 square and 100 square. 2 into 100, 200. Non-square numbers between these. 90 and 91. Both are consecutive. So 2 into 90, 180. Next 1000 and 1001, both are consecutive. So 2 into 1000, it's 2000. Okay, so very easily you can write the answers like this. Okay, next here is see. So if the number is a square number, it has to be the sum of successive odd numbers starting from 1. Okay, and clearly we can tell the sum of first n odd natural number is n square. See here, 1 plus 3, 4, 2 odd numbers, 2 square. 1 plus 3 plus 5, 3 odd numbers, 3 square, 9. So like that we can write. Okay, see here, try this. Find whether each of the following number is a perfect square or not. So here you have to remember, if a number has two same factors, then only it is perfect square. Okay, see 121 we can write as 11 into 11, two same factors, so it is perfect square. 55, 55 I can write 11 into 5, right? So not same factors, So it is not perfect square. 81 we can express as 9 into 9. So same factors now. So it is perfect square. 49, 7 sevens are 49. So it is perfect square. Same factors. Okay. Last 3 3 is 9, 3 2 6, 16. 23 into 3. So it is not, these are not same factors, right? So it is not perfect square. Okay. So these are the two try these problem solutions of page number 94. So next here, one important point. Natural number, if any natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. Okay. If we can write a number as the sum of successive odd numbers like this, then only it is a perfect square. Otherwise it is not a perfect square. And next here, another formula, if n is odd number, then n square can be write as the sum of these two are successive numbers, n square minus 1 by 2 plus n square plus 1 by 2. Okay. So the square of odd number can be expressed as the sum of two consecutive numbers. Okay. So the formula for that, n square minus 1 by 2 plus n square plus 1 by 2. That is the formula. So here express the following as the sum of two consecutive integers. Four numbers are given. So formula, n square minus 1 by 2, n square plus 1 by 2. So 21 square, it is a odd number. So two consecutive numbers, n square minus 1 by 2 and n square plus 1 by 2. So 21 square minus 1 by 2. 21 square means it's 441. 441 minus 1, it's 440 by 2. 220. 441 plus 1, it's 442 by 2. 221. So 220 plus 221. That is only in a question. The following as the sum of two consecutive integers. Sum of these. So next, by using the formula 13 square minus 1 by 2, 13 square plus 1 by 2. 13 square means it's 169. Minus 1 means 168 by 2. So 84. Next 169 plus 1, 170. 2 8s are 2 5s. So it's 84 plus 85. Next 11 square, 121 minus 1, 120 by 2. It's 60. 121 plus 1, 122 by 2. So 2 6 are 2 ones. So consecutive numbers, 60 plus 61. Next 19 square. 19 square means it's 361. Minus 1 means 360 by 2. 180. Okay. And 361 plus 1, it's 362 by 2. 181. So like this you can express as the sum of two consecutive integers. So here the main point you have to remember is we can express the square of any odd number as the sum of two consecutive positive integers. But reverse is not true. See, second one, do you think the reverse is also true? That is, the sum of any two consecutive positive integers is perfect square of a number. Give example to support your answer. Reverse is not true. Okay, no, it is not true. So any two consecutive sum is not a perfect square. For example, 5, 6 you take. Consecutive numbers only, no? Okay. And 5 plus 6 equals to 11. It is not a perfect square. 5, 6 are consecutive numbers. 5 plus 6 equals to 11 is not a perfect square. So reverse is not true. Any perfect square can be expressed as a consecutive integers, sum of two consecutive integers, but sum of two consecutive integers is not a perfect square. Okay, clear. Next, see here, product of two consecutive even or odd natural numbers. See, 11 into 13. Here we can write 12 minus 1 into 12 plus 1. So in the form of a minus b into a plus b. It's a square minus b square only, no? So 12 square minus 1. Same, 11 into 13 into 15. Middle number is there, no? So 14 minus 1, 14 plus 1. 14 square minus 1. So in general, we can say that a plus 1 into a minus 1 equals to a square minus 1. So by using this formula, we can simplify. Okay, that point they are telling. And here some patterns are given. See, one only one is there, one. Two ones, 1, 2, 1. Okay, and three ones, 1, 2, 3, 2, 1. Okay, like that the sequence is adding now. So see how many ones? Two ones are that means three ones are means three and repeating. Four ones means four and reversing 3, 2, 1 like that only na. So here write the square making use of the above pattern. So just count how many numbers are there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and reverse 5, 4, 3, 2, 1. That's it. Okay. Next 1, 2, 3, 4, 5, 6, 7 ones are there. So 1, 2, 3, 4, 5, 6, 7 and reverse 6, 5, 4, 3, 2, 1. Very simple. Okay. Actually, it is called Pascal's triangle. Next, last try this. Can you find the square of the following numbers using the above pattern? See here, 7 square 49, 1 6 is there. Then 2 fours, 1 8, 2 6. So extra 3 fours, 2 8. So number of 6 are equals to number of 8s and one more 4. Right? And last 9 is common. So 1, 2, 3, 4, 5, 6, 6 are there. So how many fours? 7 fours, right? 1 4 extra is there, no, in the pattern. So 1, 2, 3, 4, 5, 6, 7. And same number of 8s. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 and 1 9. So last one 1, 2, 3, 4, 5, 6, 7. So 7 plus 1, 8 fours. 1, 2, 3, 4, 5, 6, 7, 8. And same number of 8s. That means 7. 1, 2, 3, 4, 5, 6, 7 and 1 9. Okay, like this if you follow the pattern easily you can write. Students, these are the problems before exercise 8.1 and the introduction of this chapter. I think you understand this. Students, please like this video and please share this video with your friends and please subscribe to my channel. Thank you for watching.